Here we have the point P which lies on the terminal side of the angle theta, and we have to determine the six trigonometric ratios. So first I'm going to plot this point P on the xy coordinate system. So let me plot this xy coordinate system. So this is x and this is y, and this point P is this is x coordinate is 5 and y coordinate is -8. So I'm going to put 5 tick marks. So this one is basically 5 units, and here I'm going to put 4 tick marks. Each tick marks corresponds to 2 units. So 2 times of 4 is 8. So this is basically -8. So this point approximately it is over here. So this point is P 5 comma -8. So we will construct the terminal site. That is, we have to join this P with the origin, and we will also drop a perpendicular from this point that is at x equal to 5. Let's say this is O and this is A. So basically the distance OA is 5 units, and this distance AP is -8, or it is 8 units down the x-axis. So now we have to first evaluate this hypotenuse, because since this is angle theta. So to find the six trigonometric ratios, we need to determine the hypotenuse first. So we will use the Pythagorean identity, that is OA quantity square, that is square of the sides. Sum of the squares of the sides equals hypotenuse. So OA squared plus AP squared equals OP squared. So OA is 5 and AP is -8. So this becomes a -8 squared, and this equals OP squared. So therefore 5 squared is 25, and -8 quantity square is positive 64. This equals OP squared. So this implies OP square equals 25 plus 64 is 89. So to determine OP, we take square root on both sides. So we find the OP from this. Therefore OP equals square root of 89. So this is the simplest form. So this cannot be factored, or it's not a perfect square. So we will keep the OP as square root of 89. And so we mark this OP as square root of 89 in the diagram. So this is square root of 89. So now in the right triangle, we know all the sides, that is OA equals 5, AP equals -8, as well as the hypotenuse is OP is square root of 89, which means we can now determine the all trigonometric ratios. So first, let me start off with sine theta. The sine theta equals, according to Sokotova, this is opposite side over hypotenuse. Let's say the hypotenuse, the opposite side is -8. So I write -8 over here, divided by the hypotenuse is square root of 89. So therefore, this is -8 over square root of 89. In fact, we can rationalize this. So let's write down this as square root of 89. We multiply by the root 89 and divide by root 89. So therefore, this becomes -8 times of root 89 over 89. Root 89 times root 89 is 89. So this is the sine theta. And now we will determine cos theta. So using cos theta, we know that it is adjacent side over hypotenuse. The adjacent side to theta is 5. So I write 5 over here, divided by hypotenuse is root 89. Once again, if we rationalize this by multiplying the numerator and denominator by root 89, we will get 5 times of root 89 over 89. So this is the value of cos theta. Now we will find tan theta. This tan theta, according to Sokotova, this is opposite side over adjacent side. We see from the right triangle, the opposite side is -8, and adjacent side is 5. So we write down this as negative 8 over 5. So this is the value of tan theta. Now we will find other trigonometric ratio, that is cosecant theta, and this equals according to Sokatova, this is hypotenuse over opposite side. We know the hypotenuse side length is square root of 89 over the opposite side to theta is negative 8. So this can be written as negative of square root of 89 over 8. So this is the value of cosecant theta. Now we will find secant theta, and this equals according to Sokatova, this is a hypotenuse over adjacent side. The hypotenuse side length is square root of 89 over adjacent side to theta is 5. So we write down 5, and this is the value of secant theta. And finally we find the cotangent theta, that is COT theta. This equals adjacent side, I'm sorry, yes, in fact it is adjacent side over hypotenuse. Adjacent side over opposite side, it's not over hypotenuse. So let's find the adjacent side to theta is 5, and the opposite side is negative 8. So therefore we can write down this as negative of 5 over 8. So this is the value of cotangent theta. So we have determined the all trigonometric ratios, that is sine theta, cos theta, tan theta, cosecant theta, secant theta, and cotangent theta.